I would be happy to take any questions.
Questions?
Oh, which is okay. Thanks for the great talk. So with the 15 solar mass star, right, that has a lifetime of just some tens of millions of years, is there a timing problem in getting it to form and then tidally disrupt on that time scale?
Okay, so I would phrase that question. Is it possible for such a high mass star would be disrupted by that kind of a black hole, given the timelines? Yes, but there has been more and more research on how sensitive the star formation is around these galactic centers. So there would be these high massive stars which are rapidly formed and just fall into these supermassive centers of black holes. So there have been really coming up literature where it is showing more and more that we do not know completely what's happening around the regions around the galactic center. So that would be my answer to that question.
Okay.
Yeah, thank you. Sorry, I was looking at the wrong person because I was, my bad. Hi.
Hi, so thank you. This was a really interesting talk. As someone who also works a lot with light curves, I find it super interesting. But so I had a question about the physics-based fitting models you mentioned. So are those like open source / public? Can I go online and play with those?
Absolutely. So these models here, so these are modeled by Takashi J. Moria. So these models are public. So thank you for that question, because I wanted to highlight the significance of making synthetic light curves or models in survey passbands, because this fitting has been seamless because these synthetic light curves have been tailored to these survey passbands. And Takashi does a great job in producing these synthetic light curves in LSST passbands too. So you can easily adapt this if you can use those models in particular survey passbands. He has a suite of models from SDSS to like LSST. So these are publicly available. And it's also a shout out to the community. This is for like red supergiant progenitor models, but in order to fit it for all the type of any transient with any number of suite of models, we need to build these models. Like it could be semi-analytic, which is already in place, or it could be hydrodynamical models where the community can join in hands together to have this kind of real-time characterization. Yeah.
Okay, thank you.
You mentioned that in refit, the information from the follow-up observations is actually fed back. What happens to it?
So it is fed back to, so it is basically more data on this particular transient, which has been followed up from these observing regions, observing agents, which is fed back. So another real-time characterization at that epoch could be done, which is based on this follow-up data, and that can improve the accuracy of your predictions or forecast. So that's how it is a loop, which is fed back into the system for improving the recommendations for the next daily. So this is run daily on a daily basis, and yeah, it is great for augmenting data from survey light curves, because survey light curves can be very sparse in terms, because LSST is also going to based on its cadence. So you need to have optimum data quality for doing science on survey light curves too. So it is also a platform where you could augment on those survey light curves to derive whatever science you're interested in.
Awesome. Any other questions? Okay, let's thank Bhagya then.
Thank you.